Welcome to clickmyproject.com. We introduce about geographic image retrieval using local invariant features. This paper investigates on such class of method wherein local image regions are characteristics by feature designed to be invariant to different in appearance resulting from geometric transformations such as rotations or scaling, as well as from photometric transformations such as change in illuminations. The image region themselves are so detected in an invariant manner. This is so called local invariant features have been successfully applied to a range of standard non-geographic computer vision problems, and there has been increased interest in using them for overhead image analyzed. We demonstrate in earlier work that the SIFT features are a magnitude faster to extracted than Gabber texture features. The saliency based local feature perform poorly on the baseball, diamond, beach, golf and runaway classes. Saliency based feature extractions result in a relatively few features in these classes indicated in figures, as they tend to contain large information regions. The sparseness of the resulting bag of visual words histogram reduce their discrimination ability. This correlation is likely due to the fact that extracting SIFT descriptors, which are after all summaries of local edge informations on a regular grid, is similar to applying Gabber filters, which can also be considered local edge detectors. Finally, it is interesting that the saliency based local feature performed better than the texture features on the classes which upon first inspections appear more texture like. The system architecture considers for three main parts: pre-processing, feature extractions, retrievals. Explain about pre-processing. The input of the image is given into the pre-processing. The pre-processing method uses a small neighborhood of a pixel in an input image to get a new brightness values in an output image. Such a pre-processing operations are also called filtrations. Local pre-processing method can be divided into two groups according to smoothing, suppress noise or other small fluctuation in the image equivalent to the suppression of high frequency in the frequency domain. Unfortunately, the smoothing also blurs all sharp edges that bear important information about the image. The filters are used in pre-processing technique. IM filter function is used to remove the noise from multi-dimensional array. The input can be logical or a non-sparse numerical array, often any class and dimensions. The resulting array has the same size and the classes as the input. The computation is performed using double precision floating point numbers. The second method is a feature extraction method. It is also called a scale invariant feature transformation. It is an algorithm in computer vision to detect and describe local feature in image. For any object in an image, interesting point on the object can be extracted to provide a future descriptions of the object. Extracted from a training image can be used to identifying the object when attempting to locate the object in a testing image containing many other objects. Another important characteristic of these features is that the relative position between them in original scenes should not change from the one image to another. To perform reliable recognition, it is important that the feature extracted from the training image be detectable even under changes in image scale, noise and illumination. Such points usually lie on high contrast region of the image, such an object edges. Now we see about the output. We have clicked the main button. In dataset we have lot of image. We have selected any one of the image. I selected for 25th image and then open. The output figure window will be displayed. The output is considered for figure 1 is a original image. The original image we have selecting the road image, so output will be displayed. Now we see about the second output of the image. The second output of the image is a pre-processing of the image. The filters are used in the pre-processing technique. IM filter function is used to remove the noise from multi-dimension array. The input can be logical or a non-span numerical array of any classes and dimensions. The resulting array has a small size and the classes input. The pre-processing methods are used to removing the noise using the Gaussian filter. Now we see about the figure 3 output. The figure 3 output is a feature extraction method. It is also called a scale invariant feature transformation. In feature extractor method, to detect and describe the local feature and image for any object in an image. Interesting point on the object can be extracted to provide feature description of the object. The feature extraction method can be classified into two types. For shifting and invariant methods, the shifting method can be similarity based method. The invariant method can be classified into shape based method. It is an important that the feature extracted from the training image be detectable even under change in image scale, noise and illumination. Such points as usual lie on high contrast region of the image such as the object on the edges. We have displaying the shifting and invariant properties of the 10 images. We calculated from the scale space, then the key points are localized. Their nearby points are interpolated, the low contrast key points and the edge responses are eliminated. Then we can see about the output last final of the image. This figure of the images is retrieval. We find the illusion distance between them, one image to another image. Comparisons of all the image will be distance will be calculated. We demonstrate that the local invariant features are more effective than the standard features. A bag of visual VAT representation including saliency-based grid-based features will be extracted. Thank you.